All right, so we need to solve this equation, and I'm going to show you how to do this by something that's called clearing the fractions. But before we do anything, we need to talk about what the lowest common denominator is. And you can call it either the lowest common denominator or the least common multiple. It's the same thing. I want to really talk about what this means as far as the least common multiple. So I'm talking about the multiple of 6. All right, so 6 times 6 is 6 times 1 is 6. The next multiple of 6 would be 6 times 2, which is 12. And then the next multiple of 6 is 6 times 3, which is 18. And the next one I have is 6 times 4, which is 24. And then finally 6 times 6, which is 36. All right, so that is for the 6's. If I now look at my common multiples of 12, 12 times 12 is 1. 12 times 2 is 24. And 12 times 3 is equal to 36. And I stopped at 36 here because I knew what was kind of happening. But we're going to do it one more time. And if you look at 18, 18 times 1 is 18. And then 18 times 2 is equal to 36. Oops, I see I wrote 33. That should be 36 there. Excuse me. So what this is saying is my least common multiple between all three of them is 36. That also means 36 is my lowest common denominator. And again, how did I do that? I just said, all right, 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times, I skipped 6 times 5, and 6 times 6. And then 12 times 1, 12 times 2, 12 times 3, 18 times 1, and 18 times 2. And I do this until I get a number that all of them have in common. That's why it's called the lowest common multiple. It's the first one. All right, now, what do I do with all of that information? Now I go back to my entire equation that is up here, and I want to multiply that entire equation through by 36. Let me show you what I mean. So what I want to do is think about this as a big giant distribution problem. I want to multiply every term on the left-hand side by 36. And because we're dealing with fractions, I'm going to put that 36 over 1. And I want to multiply every term on the right-hand side also by 36. And again, because we're dealing with fractions, it's 36 over 1. So now I distribute. So I have 36 over 1 times 5 over 6x plus 36 over 1 times 5 over 12 is equal to 1 over 18 times 36 over 1. Now, the reason I'm doing it this way is because I want to reduce now. Look what I have inside here. Because I know evenly that 6 divides into 36 6 times. Then inside my parentheses, all I'm left with is 6 times 5. So that leaves me with 30x. I do the same thing for my next group of parentheses over here. I know that 12 divides evenly into 36 3 times. So that leaves me 3 times 5, which is my plus 15. And lastly, I know over here on the other side of the equation, I know that 18 divides into 36 twice. So all of that is equal to 2. So the process that I did here is I first found the lowest common multiple, or least common denominator. Then I take that and multiply it times every single term in my original equation. I reduce, and by doing this, as long as you have found the least common multiple, you will get rid of or clear all the fractions. And at this point, it's just a matter of solving the equation by subtracting 15 on both sides, which leaves us 30x is equal to positive 13, and then dividing both sides by 30. And I'm left with x is equal to 13 over 30. And I do want to make sure I show you how to put this in again. You cannot put in decimal answers for these. You must leave them as a fraction. So I'm going to go ahead and put my fraction bar. There we go. I have two fractions. I hit it twice. So I'm using my arrow button till my cursor blinks up in the numerator, and now I have 13. I'm going to use the down arrow on my cursor and put in my 30, and then I'm done, and I submit my question. And it's wrong. What did happen? What missed? Let's go back and check out the work. I made the cardinal sin, right? What did I do? I went a little bit too fast. What happens when I do 2 minus that 15? That should be a negative 13, right? Yeah, that means our final answer here is going to be that negative 13 over 30. Let's see, and you can come back here and put in that negative sign. Now that should be perfect, and you are all set. All right, let's go ahead and take a look at the next equation that we have. We're going to do this the same way, but before I start this, I do want to make sure I point out that the fact that this is 3 is a number. So whenever I have a group of both mixed numbers, or integers, and fractions, always turn everything into fractions or improper fractions first. All right, so let's look at the lowest common multiple. I have 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6, and that's all I'm going to need here to start with. And then I'm going to do 4. 4 times 4 is 1. 4 times 2 is 8. 4 times 3 is 12. So it looks like I've got to go back up to my multiples of 2, right? These are my multiples of 2 that I have here, so I have to keep going with that so I can find something common. So 2 times 3, 2 times 2 times 4 gives me 8. 2 times 5 gives me 10. 2 times 6 gives me 12. So I'm going to stop there because now I have those two matched up. The last number I'm going to use as the multiples of my last denominator, which what I have right here is my 6. So that is 6 times 1, and 6 times 2 is 12. So I have my lowest common multiple of all of them, which is 12. All right, so remember the process. The first step is to find the LCM. And the second step is I want to take that LCM and multiply it times my equation. And I do that, and I want to make sure I multiply 12 on the outside of both of those parentheses. All right, so I take that 12 and multiply it times both pieces on the left-hand side. And again, right now I'm just going to write these out because I want to make sure I show you how to reduce them properly. And then it's going to be 12 times 5/4. And again, that 12 is always understood to be over 1. And that's going to equal 12 over 1. Let me make that green because I want that to stand out as the LCM. Times 3 over 1 plus my 12 over 1 times my 5 over 6x. All right, by design, all of my fractions are now going to go away. 2 divides into 12 6 times. 4 divides into 12 3 times. And 6 divides into 12 twice. Now I just have to simplify. So over here for the first term, 6 times 7x is 42x plus just 3 times 5, which is 15, is equal to my 12 times 3, which is 36, plus the very last one, which is 2 times 5x, which is my 10x. Now we're at a point we can just solve this normally. All of our fractions are gone. So let's go ahead. Let's move the x's first. I want to subtract 10x from both sides. That leaves me with 32x plus 15 is equal to 36. Next thing I want to do is I want to subtract 15 from both sides. And I have 32x is equal to 21. And the last step is to divide both sides by 32. And again, let's put that in. It's 21 over 32 for this question. Click on your fraction button, X that out, and then click your numerator, and that would be 21, the down arrow for 32. And then I want to go ahead and submit my question. All right, we have one more of these to do. In this one, if you want to go ahead and hit pause and try it on your own first, that'd be fantastic. Now the LCM with this one is 4. So this one, the challenge with this is not finding that LCM and distributing them. It's just there's a little bit of a trick with this. So when I distribute that 4, I have 4y over 4 plus 4y over 2 is equal to 28 over 4. But for some reason, this seems to trip students up a little bit. 4 over 4 is just 1, so this is just 1y. And then what I have over here, 4 divided by 2 is 2y, and 28 over 4, or you could have just seen that those two 4's cancel out, leaves me back to 7. So we haven't done this in a while, but we need to combine like terms on this side. 1y plus 2y is just equal to 3y is equal to 7, or y is equal to 7/3. And that is it for how we are doing our fractions.